Hey there everyone, welcome to the video lecture series on Z transforms. I'm Professor Mayur Gohil. Welcome back to this video lecture series. Now we shall see some very important standard formulas which are used very often in Z transform. These are three crucial, whenever cos theta comes, you have sine theta always with it. And if you are little bit advanced in mathematics, or if you are doing engineering, then cos and sine theta are always related to e to the power I theta, right? So you have that relationship always coming into the picture. So we'll just mention that relationship here. E raised to I theta is cos theta plus I sine theta. This is the relationship, this is the angle. And if you have little bit generalized relation, e raised to I n theta is cos n theta plus I sine n theta. Okay, you always mention the brackets correctly so you do not mess up with the angle. Having said that, we go for the first formula, how to find this formula. Now the proof of this is very much a standard way of understanding. Let us see how to go about it. The first thing, we consider the function f of n equals to e to the power I n x. Okay, I n x over here. Now when we see this, we can see this with the help of laws of indices. Now what are laws of indices? They are some very simple rules are these which you learn in school level. Like if you have a to the power m n, this can be seen in two different ways. What is this? The first way is a raised to m whole to the power n. This is one way. Another way is a raised to n whole raised to m. This is another way. And this is same as a raised to nm. Okay, this is all manipulation of mathematical algebra. Okay, all this is due to computer. Okay, we have to help computer understand in a better way. That's why these many uh, copies of the same formula in a different way. Though we understood this as a law of indices, okay, at school level, but now as you proceed, if you advance in understanding, you have to understand that we have to explain this to a machine, and machine doesn't understand anything on its own initially. Now everything is possible, but you have this a raised to mn, you have to get it through a code so that computer can generate that many copies, so and get the same conclusion. So all that thing happens here. And so now we have this e to the power inx. So this e to the power inx, with this rule we will be able to see this here. See this, that we apply z transform on the function, that is correct. But now we see this e to the power inx as e to the power ix whole raised to n. Okay, we have already found the formula of z transform of a raised to n, that is z over z minus a, right? That is the formula we have found. So now instead of a, the work of a is done over here by e to the power ix. So I will write z transform of e to the power ix whole raised to n is nothing but z upon z minus e to the power ix. So this is the first formula that we get for z transform of e raised to inx. We are done with the answer for the first formula. Now we go for the next. We already have seen now that e raised to I n theta is cos n theta plus I sin n theta. Okay, so on the LHS we will be able to do that, and for e raised to ix we write cos x plus I sin x. Okay, we do that. We do the simplification of the denominator by collecting the real part and the imaginary part. Once we collect the real part and the imaginary part, we try to simplify this in a form of a complex number. So we always write a complex number as a plus bi format. That is, what is the main format is the real part is first, right? And then there is plus I times the imaginary part there. So once you have that format, you go for simplification. So in order to have that, we do this conjugate, multiply, divide the denominator, and here you get the simplification. Now when you multiply the numerator, that is okay. When you do the for the denominator, you come across a very simple and a very famous identity that you learn in school level, that is a plus b, a minus b is a square minus b square, right? And then you also know the rule that I square is minus 1. Then you substitute that and you get, for I square you will get plus, and then you expand z minus cos x the whole square, you will get using a plus a minus b the whole square. When you do, you get a square minus 2ab plus b square, right? Use that and you simplify this. On simplification of this, we get the following answer, that is z times z minus cos x plus I times z sin x over z square minus 2z cos x plus 1. Okay, we got this. Now, as we saw in the previous part, that e to the power I n theta can be written as cos n theta plus I sin n theta. We write e to the power I n x as cos nx plus I sin nx. Okay, that's what we have. And we now on the RHS separate the denominator. We give that denominator to the real part and we give that the denominator to the imaginary part also. On the LHS, what has happened? Can you see that the z has been distributed over the plus sign, and I is as a constant has been taken out. This property has a very significant name that we have seen in our second or third video lecture, in which the definition of the Z transform was dealt along with its property known as Z transform is a linear operator. Okay, because I'll just write here, since Z transform operator is linear. So having said that, we have this in the LHS and this is the RHS that we had. Now we compare the real and the imaginary parts. We get that Z transform of cos nx is z into z minus cos x over z square minus 2z cos x plus 1, and Z transform of sin nx is z into sin x over z square minus 2z cos x plus 1. See there, it's very easy. The denominator is very simple. You can easily remember it. It is a common denominator in both the terms, sine as well as cosine. So only thing what we need to remember is, for cos, it in the numerator there is z into z minus cos x, and in the sine, there is z sine x. Remember here one thing very careful, that the answer of z transform of cos nx and z transform of sin nx is independent of n. The n has not bothered anywhere in the process. So please be careful that it is not going to be affected. This is one very cool feature of Z transform and its answers. Now, these are the two most important formulas that I would like you to make note of them, and please make this note for yourself that we have seen the formula for Z transform of e raised to I n x as Z over Z minus e to the power ix. Okay, so with these three important formulas, I conclude my video lecture over here for this topic right now. Regarding them, we will soon see the important examples related to this in the next video lecture. I hope you liked it. Please hit like button, share it with your friends. Those who find this topic useful, I shall soon see you with this in topic further video lectures in the new video. Thank you.